Example 6. Isopropyl alcohol, a substance sold as rubbing alcohol, is composed of carbon, hydrogen, and oxygen. Combustion of 0.255 gram of isopropyl alcohol produces 0.561 gram of carbon dioxide and 0.306 gram of water. Please determine the empirical formula of isopropyl alcohol. First, we need to summarize the most important information, numbers with units, and what we are looking for are considered as the most important information. If there is a chemical reaction, a balanced chemical equation is also considered as the most important information. When we read the problem, we find the keyword combustion. If you remember, combustion is a chemical reaction between a substance and oxygen. Clearly, this is a chemical reaction. We need to write down a balanced chemical equation. However, we do not know the formula of isopropyl alcohol. We cannot balance the equation. As you can see here, I use IPA to represent isopropyl alcohol. This will save us time. Then we will put down the numbers with units below the corresponding chemical of the chemical equation. Next, we will conduct some analysis to see how we can find a solution for the given problem. First, we need to refine our goal. From the problem, we know that IPA contains carbon, hydrogen, and oxygen. To find the empirical formula of IPA means we need to find the values of X, Y, and Z. X, Y, and Z are the smallest whole number moles ratio between carbon, hydrogen, and oxygen. Then let's see what we have. We are provided the mass of carbon dioxide. We can find the mass of carbon and the mass of oxygen. From the chemical equation, the mass of carbon in carbon dioxide must be the same as the mass of carbon in IPA because there are only two reactants and the other reactant is oxygen. It does not contain any carbon. Similarly, we can find the mass of hydrogen in IPA. But we cannot use the mass of oxygen in carbon dioxide and the mass of oxygen in water to find the mass of oxygen in IPA because the second reactant, oxygen, also contains oxygen. But since we know IPA contains carbon, hydrogen, and oxygen only, we know the mass of carbon and the mass of hydrogen in IPA. We know the total mass of IPA. We can find the mass of oxygen. We also know that we can convert the mass of hydrogen to moles of hydrogen. We can also convert the mass of carbon to moles of carbon and the mass of oxygen to moles of oxygen. If we know the moles of hydrogen, the moles of oxygen, and the moles of carbon, we can find the smallest whole number moles ratio between the three different elements. At first, you may not like this map, but let me teach you a trick. When you start to use this map, you always start from a place there's no arrow point to. You can start from here, you can start from here too. But you cannot start from here, because if you follow the arrow, you can see that we need to know this information and this information. Therefore, we will start either from here or from here. We can start from the mass of carbon dioxide to find the mass of carbon in carbon dioxide. We cannot continue along this path because we need to know this information, which we don't. Then we will go back to a different place there's no arrow point to. Now let me show you the work, the details of all steps. You may have already noticed I calculate the mass of carbon and calculate the mass of hydrogen in a slightly different way. When I calculate the gram of carbon, I first convert to the moles of carbon dioxide, then convert to the moles of carbon, and then to the mass of carbon. When I calculate the mass of hydrogen, I just use the definition of the percentage of mass of an element in a molecule. From our calculation, the final answer, the empirical formula of IPA should be C3H8O. At the end, I want to emphasize, during exam or quiz, I do not need this map. If you put this map into an exam or quiz, it's fine. All I need is this part. Can you follow my example to work out this problem by yourself?